All right, this will be Chapter 7 of the Helicopter Flying Handbook. Chapter 7 is Helicopter Performance. Introduction. A pilot's ability to predict the performance of a helicopter is extremely important and helps to determine how much weight the helicopter can carry before takeoff, if the helicopter can safely hover at a specific altitude and temperature, and the distance required to climb above obstacles, and what the maximum climb rate will be. All right. Factors affecting performance. A helicopter's performance is dependent on the power output of the engine and the lift produced by the rotors, whether it is a main rotor or tail rotor. Any factor that affects engine and rotor efficiency affects performance. The three major factors that affect performance are density, altitude, weight, and wind. The Pilot's Handbook of Aeronautical Knowledge, FAA H-8083-25, discusses these factors in great detail. Moisture, humidity. Humidity alone is usually not considered an important factor in calculating density, altitude, and helicopter performance. However, it does contribute. There are no rules of thumb used to compute the effects of humidity on density altitude, but some manufacturers include charts with 80% relative humidity columns and additional information. There appears to be approximately 3 to 4% reduction in performance compared to dry air at the same altitude and temperature, so expect a decrease in hovering and takeoff performance in high humidity conditions. Although 3 to 4% seems insignificant and can be the cause of a mishap when already operating at the limits of the helicopter. Weight. Most performance charts include weight as one of the variables. By reducing the weight of the helicopter, a pilot may be able to take off and land safely at a location that otherwise would be impossible. However, if even a doubt about whether a takeoff or landing can be performed safely, delay your takeoff until more favorable density altitude conditions exist. If airborne, try to land at a location that has more favorable conditions, or one where a landing can be made that does not require a hover. In addition, a high gross weight, the increased power required to hover produces more torque, which means more anti-torque thrust is required. In some helicopters during high altitude operations, the maximum anti-torque produced by the tail rotor during a hover may not be sufficient to overcome torque, even if the gross weight is within its limits. The wind. Wind direction and velocity also affect hovering, takeoff, and climb performance. Translational lift occurs anytime there is relative airflow over the rotor disc. This occurs whether the relative airflow is caused by the helicopter movement or by the wind. As wind speed increases, transitional lift increases, resulting in less power required to hover. The wind direction is also an important consideration. Headwinds are the most desirable as they contribute to the greatest increase in performance. Strong crosswinds and tailwinds may require the use of more tail rotor thrust to maintain directional control. The increased tail rotor thrust absorbs power from the engine, which means there is less power available to the main rotor for the production of lift. Some helicopters even have a critical wind azimuth of maximum safe relative wind chart. Operating the helicopter beyond these limits could cause loss of tail rotor effectiveness. Takeoff and climb performance is greatly affected by wind. When taking off into a headwind, effective transitional lift is achieved earlier, resulting in more lift and a steeper climb angle. When taking off with a tailwind, more distance is required to accelerate through transitional lift. We're going to hold off there. That is page 2 of 6 of chapter 7. All right. And that was factors affecting performance. That's the moisture, weight, and winds. See ya.